So this question is about a circular clock face, and it's a grandfather clock, which means it's in this kind of tower encasing. We're told that the diameter is 30 centimeters and at its lowest point is 125 centimeters from the ground. And the length of the minute hand is 15, whereas the hour hand is 10. And all of this is labelled in the drawings for us. The first part of the question is to write down the size of the angle between the two hands at 3 o'clock or 3 p.m. We can see here they've actually drawn that for us, and it's just a right angle. We can see it's vertically up and then it's horizontal, so it's just 90 degrees. And then the second part is to calculate the distance between the tips of the two hands. So if we draw out that triangle again, we can see we've got this right angle triangle. So we have our hour hand pointing up to the 12 and our minute hand pointing across to the 3. This is 10 centimeters and this is 15 centimeters, and we know it's right angled. And that means that we can use Pythagoras to find the distance between them. So 15 squared plus 10 squared is equal to h squared, which is this distance here. And if I use my calculator or numeric solve, I find that it's just 18.02 centimeters. And that's the distance between the two. So there's 1 mark there for the 90-degree angle, and then I would guess for the 2 marks, one of them is for the use of Pythagoras and one is for the answer 18.02, or to 3 significant figures there, it's 18.0 centimeters. And then the next part of the question says that the height of the tip of the minute hand is modelled by this function with cos. We're told that t is the time in minutes after 3 p.m. and that the function is the height. And they've got the sketch there for us, and we need to write down first of all the values of m and n. Now we can see on the graph here that m is the highest point it gets to and n is the lowest point it gets to. So if you think about your clock face again, it gets as high as this point here and as low as this point here. So these 2 points. Now we know that there is 120 centimeters until the bottom. So if our hand reaches the bottom, then that would be the 120. And then if it reaches the top of the clock, it's going to be the 120 plus the 30. And that's the highest point it gets to. So we can use that in the second part of the question. So it's just 120 for the lowest point, and then 120 plus the 30, which is 150 for the highest point. And then now that we've found that out, we need to find the values of A, B, and C, or A, B, D, for the modelling part of the question. Now we know that the A value here is the amplitude. So this is how much it varies up and down. So let's first of all draw on my midpoint. That's always a good place to start there, which is going to be in between 120 and 150. So the middle point there is going to be 135. So 135 there. And again, if we look back at our clock hand, we can see that because it's 120 plus 15 to get to the midpoint. Then we can find the A value, which is the amplitude of how much it increases and decreases. And we can see that that's just 15 for each time. It's the length of the minute hand. And then for B, it's the length of the wave. So it's 360 divided by how long it takes to do a full wave, which is 60 minutes, because the minute hand here goes the full way around the clock every 60 minutes. So divided by 60, and that gives us 6. So I now know the values of A, B, C, and D, which means that my equation there, if I wanted it, is 15 cos 6t plus 135. And then the second or the third part of the question here is that we now have the modelling of the hour hand. So again, as it models as it goes around, where t is the time in minutes, and again the function there is the height above the ground. So we need to first of all show that q is equal to 0.5. Now q is this one here, it's the length of the wave, so 360 divided by, and this is how many minutes it takes to do the full rotation. Now for an hour hand, if we think about the hour hand here, it's going to take the full time to get back to 3 o'clock in order to do, to get to 4 o'clock in order to do the full rotation. So that would be 720 minutes, and that's why it's a half. So 720 minutes in order to go the full way around. And then we need to find the value of p. Now for this one, for p, if you think about the wave here, it starts off by going lower. So it starts at the midpoint and then it decreases before then increasing back to the midpoint, increasing to the highest point and then decreasing back to the midpoint. So if we were to draw that wave, for example, it starts at the, let's move this down, it starts at the midpoint, and then as it gets towards 6 o'clock, it gets to its lowest point. So this would be, for example, 6 p.m. And then it moves higher back to the midpoint at 9 p.m. before going even higher at 12, and then coming back to the midpoint here at 3 p.m. or 3 a.m. So that's going to be the full wave. Now, because it's starting as a midpoint, we know that it's sine, which is also given to us. However, this one goes downhill first, whereas usually sine goes uphill. And when that happens, it means it's a negative amplitude. And the amplitude there, if you think about our wave, is just that it is increasing and decreasing by 10, which is the length of that hand. So 10, and therefore my answer there is just negative 10 for p. And then it says to find the height of the tip of the hand above the ground at 4 p.m. So at 4 p.m, if we think about our clock, let's do this in a different colour. So this is our clock face, this is our 3 and 4. Now, if we're trying to find out the height at 4 p.m, we know that this is the hour hand, which is a length of 10. We also know that this angle here is 30 degrees, which is just 360 in the circle divided by the 12 numbers on a clock. So we can now find out this height here, or this length here, because that will help us to see how much we need to subtract from that usual kind of midpoint value. So because it's a right angle triangle here, we can just use SOHCAHTOA, and therefore we have the opposite value from the angle, which is the x, and the hypotenuse, which is 10. So that means that we can use sine of the angle. So sine of 30 equals x over 10, opposite over hypotenuse, and typing that into numeric solver tells me that I have an x value of 5. So that means that the height above the clock is the 120 plus the 10 centimeters here, even at this point, the 10 centimeters. If the clock face is 30 and this is only 10 and 10, that means that we have an additional kind of 5 as a gap here and here. So that means that normally for this clock, I would have 120 added to my 5 added to my 10, and that would be my midpoint value. So that would be 135. But I need to subtract this amount here, which is the height it's lost. So it's 135 minus that 5, and therefore it's 130 centimeters above the ground. And then part F says find the first time after 3 p.m. that the tips of the two hands are the same height. So if we use the model we've created here, we know that this is minus 10 sine of 1/2 t plus, and we know that it's the same midpoint value that it's oscillating around. So it's the same one as the previous question here, which was 135. So now on my calculator, all I need to do is model the two graphs. So I have the original kind of minute hand, and then, the minute hand, and then the hour hand, which is much slower at kind of oscillating through. So we're going to go to our GDC and type those two equations in, or the two models in. So the first one is the hour hand, which is minus 10 sine of 0.5x plus 135. And then the second one was the minute hand that we found, which is 15 cos of 6x plus 135. Now, obviously, if you got the first or the second part of those models incorrect, you would still get the follow-through marks for this. So if you showed that you had clearly used both of the equations that you'd found, and then you'd graphed them, then that would still give you the same marks. So for the window, we don't really need a negative section. I tend to add one just to have the axis on show. But the maximum value, it's going to be quite large here if we think back to our previous graphs and this graph. So let's just put 720 for now. And the y value, we know that we're talking about distances between around about 150 and 120. So let's make sure that we're going as high as 150. And we can see there the two different graphs. So we have the hour hand in blue and the minute hand there going much faster in red. And it's the first time that they're equal. So we're interested in this point here. So second function, trace intersection. Make sure we go closer to the point that we want to find, which is somewhere here. And we can see there that the first time it happens is at 15.88. So 15.88. So if I go back to my exam paper, so it happens at 15.88. Now we need to convert that into the time. So that is approximately 16 minutes. Oops, writing on the wrong section here. So 15.88, which is, it says correct to the nearest minute. So 16 minutes into this kind of cycle, which if it starts at 3 p.m. would mean that it happens at 3:16 p.m. So that last part there is just using the two functions that you've done. And if you have shown clearly what your functions are, then you would still get the marks for that part of the question.